If you wanted to be successful, do follow experts. Hi everyone, my name is Sheikh Hussain. I have been teaching chemistry for the past 22 years for IIT JEE, NEET and state board exams. In this video series, I am going to explain all important questions for intermediate for the students who are studying in Andhra and Telangana. I will provide short, simple and to the point explanation for all the answers to help you score full marks. The study material I am going to use in this video series is carefully prepared by my friend Santosh Kumar Reddy, PGT Chemistry. For regular updates, do follow my channel and join our WhatsApp group using link in the description. Hello everyone, in this video we are going to discuss one of the very important questions from 15th group elements. How is ammonia manufactured by Haber's process? Explain the reaction of ammonia with zinc sulfate, copper sulfate and silver chloride. Okay, let's discuss. Here the most important part is this reaction. This reaction you should write without any mistakes. N2 plus 3H2, 1 mole of nitrogen, 1 mole of nitrogen N2 and 3 moles of hydrogen 3H2 gives 2NH3. So, 2 moles of ammonia. So, here one more important point we need to remember is number of moles of reactants and products. Here reactants 1 mole of nitrogen, 3 moles of hydrogens, total 4 moles and 1 plus 3, 4 moles and the product is 2 moles. You just remember number of moles of reactants 4 moles and number of moles of product 2 moles. Means reactants are in a less number, reactants are in more number, product is in less number. And delta H is equal to minus 46.1 kilojoules per mole. That means it is a minus is there, no? So it is an exothermic process. This is an exothermic process. Right, means excess of heat will be released. This part you have to write without any mistakes. Now here in this you add few more points. It is a reversible process and also exothermic reaction. Is a reversible process. You can see here double arrows forward and as well as backward. It's a reversible process and also it is an exothermic process. So minus 46.1 kilojoules of energy is releasing. And for all, by considering all these conditions, and we can apply Le-Chatelier's principle. According to Le-Chatelier's principles, and there are certain optimum conditions, means suitable conditions to get more product in Haber's process. So what are the optimum conditions? The optimum conditions are low temperature, that is around 725 Kelvin. We can write 750 Kelvin also, no problem. And high pressure 200 atmospheres, and iron is used as catalyst and molybdenum act as promoter, right? All these conditions you have to write. See here what are the optimum conditions. Optimum conditions are low temperature, high pressure, and we use catalyst iron as catalyst and molybdenum as promoter. Here the value of temperature can also be mentioned. So it is around 725 Kelvin and high pressure, this pressure is around 200 atmospheres and iron is catalyst and molybdenum is taken as promoter. These are the things we need to write without any mistakes. Next we will come to chemical properties. How ammonia reacts with zinc sulfate. So ammonia solution reacts with zinc sulfate to form a white precipitate of zinc hydroxide, ammonium hydroxide. See here ammonia solution. Ammonia solution is nothing but ammonium hydroxide. So just to make you understand this part, I will show you how ammonia and ammonia solution both are very ammonia NH3 plus water. This is called ammonia solution, NH3 and H2O. Now NH, so here how many hydrogens are there? Here 3 hydrogens are there, here 2 hydrogens. You can remember water as H and OH. So you take one hydrogen from water and add to NH3, then it becomes NH4. You take one hydrogen from water and add this hydrogen to ammonia, you get NH4, and what left here? OH is left. So NH4OH. This is nothing but ammonia solution. Ammonia solution can also be written as NH4OH. Since in the reaction it is mentioned the ammonia solution, so we have taken NH4OH. This ammonia solution NH4OH reacts with zinc sulfate. You do one thing, this zinc now combines with these OH groups. How many OH groups are there here? 2. This 2 is common for both. So zinc combines with these 2 OH groups, becomes zinc OH taken twice, that is called zinc hydroxide. It is a white precipitate. And what are the things left in our reactant side? This SO4 is left, and 2 NH4 molecules will left, 2 NH4 ions will left. So NH4 taken twice and SO4. These 2 NH4s will be left, SO4 and 2 NH4, that becomes NH4 taken twice, 2 NH4s and SO4. This is called ammonium sulfate, ammonium sulfate. Ammonium sulfate we found. That's all. That's very simple. And the next reaction of ammonia with copper sulfate. So this reaction is quite simple, this one and the last one. Here in both reactions we will get complex compounds with AgCl and copper sulfate. You do one thing, you take this SO4 out and add these 4 ammonia molecules with copper, Cu, NH3. This Cu combines with this NH3. How many NH3 molecules are there? 4. So Cu combines with NH3, taken 4. Why we have written taken 4? There are 4 ammonia molecules, and you keep all these in a square brackets. You see, at the starting and ending there are square brackets. So if you write any compounds in the square brackets, and it represents as a complex compound, and you keep this SO4 outside, you will learn about these complex compounds clearly in the chapter D and F block elements and coordination compounds. So a deep blue color complex compound is formed. That's all, very simple. Copper combines with 4 ammonia molecules, CuNH3 taken 4 within the square brackets, and this SO4 is outside the square brackets, and this is a complex compound. It is in deep blue color. And in your practicals, second year practicals also, you learn about this reaction. Next one, reaction with AgCl, silver chloride, AgCl plus 2NH3. Here the metal Ag, in the previous one the metal copper combines with 4NH3, no? Here Ag combines with these 2 NH3 molecules, Ag, NH3 taken twice, keep all these things in a square brackets, and this Cl outside the square brackets, outside the complex, and a colorless complex will be formed. So this is a complex. Ammonia reacts with AgCl to form a colorless complex compound. Ammonia reacts with AgCl to form a colorless complex compound. So these are the chemical properties of ammonia with zinc sulfate, copper sulfate and AgCl. So this question may ask for 4 marks or sometimes 8 marks, and you better add these points also, that is a reversible reaction, exothermic reactions, and according to Le Chatelier principles, these are the favorable conditions or optimum conditions: low temperature, high pressure, iron catalyst, molybdenum as promoter. Share these videos with your friends, and we will meet in the next video.